Now we have to discuss students T distribution. The students T distribution is introduced by William S. Gossett. He's a very famous English statistician because of his certain professional restrictions. All his publications were given in the pseudonym student. That's why we have the name students T distribution. Here we have a real valued random variable T. That means a random variable with range that complete real line minus infinity to plus infinity. It is said to follow student's t distribution with n degrees of freedom if its probability distribution is f of t equals gamma n plus 1 by 2 by root n gamma 1 by 2 gamma n by 2 into 1 by 1 plus t square by n all raised to n plus 1 by 2. Here the variable t has a range between minus infinity to plus infinity, that is the entire real line. Earlier we found normal distribution with the total range of variation as minus infinity to plus infinity. So this also has some similarities with the normal distribution. Other similarities in the sense of the symmetric property. In normal distribution, we found that a function will be generally symmetric if g of a plus x is equal to g of a minus x, where a is said to be the line of symmetricity. That is, gx is said to be symmetric if about a, if g of a plus x is equal to g of a minus x. That's how we have normal distribution symmetric about x equal to mu, because f of mu plus x is equal to f of mu minus x. Now in student t distribution also we can observe this property. If you write t as 0 plus t, that is 0 plus t square, which is t square itself, this will be 1 plus t square by n all raised to n plus 1 by 2. Next, when we write t as 0 minus t, 0 minus t square, which is again t square, which means that f of 0 plus t is equal to f of 0 minus t. We shall take the pencil also. We can note that f of 0 plus t is equal to f of 0 minus t, which means that the function is symmetric about t. So now we denote this using the notation t follows t of n. Here this t is the variable, the left side, and right side t represents the distribution t, and it is addressed in terms of the only one constant of the distribution, that is n, that is t follows t of n. Now we come to the remaining properties of student's t distribution. We can see that student's distribution has mean and 0 at 0, and variance is n by n minus 2. That is, e of t is equal to 0 and v of t is equal to n by n minus 2. So the graph is symmetric about t equals 0. You can see that when we come to the properties, since this is a symmetric function, its mu3 also will be 0. Therefore, the odd central moments, odd order central moments of t distribution are 0, and therefore beta 1 is 0, and therefore this normal distribution, t distribution has the frequency curve like this. Here we have the point of symmetricity 0, and for different values of n is given here 1, then 3 and 30. And that's about the frequency curve. It is symmetric about 0. Total range is from minus infinity to plus infinity. Now next we have a relation connecting the standard normal and chi-square and t. That is, t set and chi-square are two independent random variables. Set follows standard normal, chi-square follows chi-square. Then this relation shows this random variable following t distribution with n degrees of freedom. This t is known as student's t statistic. T equals set by root of chi-square by n follows t distribution with n degrees of freedom. And this is used for, applied for constructing a statistic following student's t distribution with the help of a sample drawn from a normally distributed population. For that, we have here a sample of size n taken from a normally distributed population with mean mu and standard deviation sigma. Earlier we found that x bar follows n mu sigma by root n. Yes. X bar follows n mu sigma by root n. Therefore, x bar minus mu divided by sigma by root n follows n01. Now, chi-square equals n square by sigma square follows chi-square distribution with n minus 1 degrees of freedom. So, making use of these two expressions, we can formulate a variable following chi-square distribution. Here, we place x bar minus mu divided by sigma by root n in numerator and n square by sigma square in the place of chi-square in denominator. That's done here in this equation, and therefore we have, if you make some simplifications, we get t equals x bar minus mu root n minus 1 by s follows t distribution with n minus 1 degrees of freedom. And this statistic is used in situations where standard deviations of population following normal distribution is unknown and sample is small in size. We can use the application of this statistic in interval estimation and also in testing of hypothesis. Next, we come to various applications of student t distribution. It is used to test whether mean of a normal population has a specified value, and moreover, the two independent normal populations have equal mean when standard deviations are not given and not known, and also samples are small in size. The difference in observations of dependent samples, and moreover, the correlation coefficient has a specified value. Next, we have the Snedeker's F distribution. F distribution here given as the PDF. F of f equals n1 by n2 whole power n1 by 2 f raised to n1 by 2 minus 1 beta n1 by 2 comma n2 by 2 1 plus n1 by n2 f all raised to n1 plus n2 by 2 f greater than or equal to 0 and n1 comma n2 greater than 0. So here the variable f is non-negative and its range is 0 to infinity, and this equation has two constants n1 and n2, and therefore those two constants are here considered in the notation. It is addressed in terms of f follows f n1 n2 and their values are greater than 0. We also have a new mathematical function called the beta function. It is another mathematical function with a range of variation 0 to infinity, and it is considered in this equation of F distribution PDF. So we have some other properties of F distribution. Its mean is n2 by n2 minus 2 and n2 must be greater than 2. Its second moment d of f square is here given n2 square into n1 plus 2 by n1 into n2 minus 2 into n2 minus 4, n2 greater than 4, and this is the variance, and its equation equation of the mod is n2 into n1 minus 2 by n1 into n2 plus 2. We can note that mean is always greater than mod in this case, and therefore frequency curve of F distribution is positively skewed. And there is another relation connecting chi-square distribution and F distribution. It is the ratio of two chi-square random variables have F distribution is given in this equation, that is F equals chi-square 1 by n1 divided by chi-square 2 by n2 follows F distribution with n1 and n2 degrees of freedom. And we have the different applications of chi-square F distribution. F distribution is used to test the equality of two population variances, and also the F test for significance and observed correlation coefficient. In ANOVA, we apply F distribution. Next, we have the concept of degrees of freedom. It represents the number of independent parameters involved in the formulation of a random variable following that distribution. And so in property 9 of chi-square distribution, we notice that there are n independent random variables in the formulation of chi-square distribution, and that's how we have this degrees of freedom as n. Now, next is in the case of a sample drawn from normally distributed population, x1, x2, etc., xn, the number of independent variables will be n minus 1 because x bar also appears in that equation of s square. So, therefore, the number of independently possible variables are only n minus 1. Suppose x bar value is known to us and we have three variables, so we can freely choose only two variables as far as the value of x bar is known to us. That's given in this example. If x bar is 25, x1 is 23 and x2 27, that must be that is necessarily we should choose x3 is 25. Then only we will get x bar 25. So if x bar has been fixed and we have n variables x1, x2, etc., xn, we can choose only n minus 1 variables freely because of this fixed value of x bar, and that x bar appears in the equation of s square, and therefore we have only n minus 1 freely choosable random variables in the distribution of n square by sigma square. That's how it has n minus 1 degrees of freedom, and that is given here in the chi-square equal to n square by sigma square. This chi-square distribution has n minus 1 degrees of freedom. It's about the concept of degrees of freedom.